All right, folks, we're going to graph quadratic inequalities. This is going to be fun. We've graphed quadratics before. We have graphed inequalities before, but now we're going to graph quadratic inequalities. And the process is basically taking those two ideas we've seen before and just putting them together. Just doing the same. We're doing the same thing, but just back to back. So here's the process that we'll kind of just keep up as I go through the couple of examples here. First, we're going to graph the boundary parabola. We know how to graph parabolas. We've seen it before. We've done it before. We plot the vertex. Then we graph 4 other points by using kind of that line of symmetry and where that is. And then we can kind of reflect those things. Then we decide is it solid or dotted. So this is where the inequality portion comes into play. Is it strictly less than or greater than? Or is it less than or equal to or greater than or equal to? So that dictates whether or not this is solid or dotted line. Then we shade by using a test point in one side of the boundary and plug it in and see if it works. And if it works, then we shade that side. That's where the solutions are. And if it's false, then that's where the solutions aren't. And we shade the other side of the boundary parabola. So what does this look like? Here's a whole bunch of information. So let's say we have some quadratic or a quadratic inequality that is in vertex form. This is in vertex form. Y is less than or equal to 2 times the quantity x minus 3 squared minus 4. The vertex of this parabola is 3, negative 4. I can see that because it's in vertex form. It's the opposite of 3 and then negative 4. So that's the vertex. So we plot the vertex and 2 points on each side of the vertex because we know that the line of symmetry goes through the vertex. Then we decide, is it solid or dotted? Well, this is going to be solid, and the reason it's solid is because it's or equal to, which means the points that are on the boundary parabola would satisfy this inequality. Then we find a test point. We're going to use 0, 0. So let's look at what this graph looks like here. So here's what the graph is. 3, negative 4, right there. That right there is the vertex. We know that from vertex form. Then we plot any 2 points on either side of the parabola. So it looks like we plugged in 4 and we got out negative 2. So when I plug in 4 in for x, what comes out for y is negative 2. And then I can reflect that over the line of symmetry, which is right here. So this point, and we have another point here. Looks like another one we can plug in is, let's say, 5. Looks like we plugged in 5. And if we plug in 5, it looks like we get out 4. So if you plug in 5 for x, then what comes out of this is 4. So that's another point. We reflect that over the line of symmetry, and there we go, and we have our parabola. It's a solid line because it's or equal to. Now we pick a test point. Looks like the test point that we picked here is 0, 0. 0, 0 is not on the parabola, so it's a fitting test point, and 0, 0 is kind of nice to work with. When we plug in 0, 0 into this parabola, x is 0 and y is 0, this is what we end up with. 0 is less than or equal to 2 times the quantity 0 minus 3 squared minus 4. 0 minus 3 is negative 3. Negative 3 squared is 9. 9 times 2 is 18. 18 minus 4 is 14. 0 is less than or equal to 14. That is a true statement. That means 0, 0 is a solution to this inequality. Therefore, all of the other points that are on the same side of the parabola as 0, 0 are solutions, which is why all of this is shaded in, and everything kind of inside this parabola, so to speak, is not a solution. So this is not a solution to this, quadratic inequality. Keep wanting to say parabola. That's what that looks like. Do another one in vertex form. Y is less than negative quantity x minus 4 squared. So the vertex here is 4, 0. It's the opposite of what's inside the parenthesis. There's nothing on the outside. So 0 is the y coordinate of the vertex. And then we can plot the vertex in 2 sides on each side and then reflect them. It's a dotted line because it's strictly less than. Then we'll find a test point. So let's see what this graph looks like here. So here's that vertex. And then we can pick 2 points to plot. It looks like, I don't even know what we picked here. Perhaps we picked, I suppose you could pick maybe 2, or you could pick, yeah, it looks like we picked 2. Looks like if you plug in 2, you get out a negative 4. And then you can reflect that over here. Line of symmetry is right there. Looks like we might also be able to pick there. 6, 7. That looked like 7 was picked either. I'm not sure what other one was picked besides 2. I'm not sure. Can't quite tell from that. Maybe 3. Pick anyone. Either way, we get kind of the gist of hopefully where this comes from here. If not, please follow up, because that can be a deal breaker with graphing the parabola. Dotted line again because it's strictly less than. Let me pick a test point. Once again, 0, 0 is clearly not on this parabola, so we could pick 0, 0. So we plug in 0 for x, plug in 0 for y, and we get this right here. 0 is less than negative quantity 0 minus 4 squared. 0 minus 4 is negative 4. Negative 4 squared is positive 16. And then we tack on this negative at the end, which is negative 16. So 0 is less than negative 16. That's not true. 0 is not a solution. Therefore, everything else on the same side of that parabola is not a solution. So therefore, all of the solutions are kind of inside that parabola. That's what that looks like. But what if it's in standard form? We've graphed parabolas in standard form before, and what we're going to do, if it's in standard form, is use h equals negative b over 2a, which is the line of symmetry, or the x-coordinate of the vertex, and then evaluate the quadratic at that point to find the y-coordinate of the vertex, and then we're right back to where we were before. So if it's in standard form, as it is right here, it's a quadratic. I know that because it's x squared. The line of symmetry is going to be x equals 2, because negative b here is negative 4, so in this case b is 4, over 2a, and a is 1, so 4 over 2 is 2. So the x-coordinate of the vertex, or the line of symmetry here, is 2, and then the vertex is negative 3. This negative 3 comes from plugging this 2 into the quadratic inequality, or equation in this case, and finding out what the y value will be. If I plug in 2 for x here, this will simplify to negative 3, so that's the vertex. Now we're right back to where we were before. We have the vertex. It's going to be a solid line. We're going to use a test point, 0, 0, and then we'll get this true inequality. So here's what the graph looks like. So the vertex is 2, negative 3. That's what this point is right here. Plot 2 points on each side. It looks like we picked here 0. Looks like we plugged in 0. Came out as 2, and you can reflect that. And it looks like we also maybe picked 1. Looks like when we picked 1, we got out a negative 2. That came out, and then we reflect that over here. It's a solid line because it's or equal to. It's strictly equal to. So that's where the solid line comes from. Then we pick that test point, 0, 0. So you plug in 0 into each of these things. So 0 squared minus 0 times 4 plus 1. That results in 0 is less than 1. This is a true statement. 0, 0 is a solution. Therefore, everything else on the same side is a solution to this quadratic inequality. One more. Y is less than, or y is strictly less than, negative 3 x squared plus 5. The line of symmetry is going to be 0 because we have negative b. There is no b here. There's no just x term, so b is 0 over 2 times a, which is 6, and 0 divided by anything is 0. So 0 is the x-coordinate of the vertex. So 0, 5, because when you plug in 0 here, we get out 5, so that's the vertex. So we can plot those, that point, 2 points on each side. The test point's going to be 0, 0. That won't work. That will work because it's clearly not on the parabola. So we have this parabola here. There's our vertex, 0, 5, and then we pick 2 points to plug in. So I can plug in like 1. I think we get out 2. You can reflect that. Then we can plug in maybe 2, get a number out. What would come out there? 4, negative 12, negative 7, something like that. Let's say negative 7. You can reflect that there. Dotted line is strictly less than. Plug in 0, 0. 0 is less than negative 3 times 0 squared plus 5. That results in 0 is less than 5. That's true. 0, 0 is a solution, so is everything else inside. So we shade inside there, and we have graphed quadratic inequalities.